Hi, I'm Jani from Conformiq. In this video, I'll first say a few words about our technology and then show you a demonstration. Conformiq Designer is a tool for automated test design. This means that it automates the process of thinking of a set of test cases to test a system. In manual test design, what you do is that, as an engineer, is that you take a specification and then based on this specification you apply certain test design heuristics on top of it and then come up with a set of test cases. In automated test design, you create a model of the specification based on the specification, and then Conformiq Designer applies these same test design heuristics automatically on top of this model. The tests that you generate with automated test design are executed exactly the same way as they are executed when they are generated manually. So Conformiq Designer just feeds the test execution system with automatically generated test cases. So in the process flow you have a model, then you have the test generation, and then you have test execution. The way this works in practice is that you see the system under test as a black box, which has a number of interfaces. Then you create a model which is a kind of an image of this black box with the same interfaces. Then you give this model to Conformiq Designer and it inverts the model into a set of test cases. So the way you should think of the model is that it's kind of a rewriting the specification in a language that Conformiq Designer understands. And then based on that, it applies the same test generation heuristics or test design heuristics automatically, then basically eliminating the hard work of figuring out what the test cases would have to be. In the demonstration that I'll show, I will show a model of a SIP or Session Initiation Protocol client. Session Initiation Protocol is a protocol widely used in voice over IP. It's based on a document called RFC 3261. The model is not a model of the complete RFC. Basically, we are modeling the call setup, call cancelling, and call termination of this RFC. If you think of what the SIP client is in real life, it's basically a component that runs on a mobile client, sits between a user interface and then the network. So the user asks the phone to set up a call, it sends SIP requests to the network and receives SIP responses from the network, and so on. Then if we now think of what this black box in this particular demonstration is like, it's basically so that there is the user interface through which the phone receives these user interactions from the user. Towards the user, the client sends times out in case an attempt to establish a call with the other side times out for some reason. Then there is a network interface through which the client sends requests and responses to the network and receives requests and responses from the network. And then the rest of the model, as we'll see, is basically created using this language that we have defined as the system block for the model.
What I'll show you next is what the model for the SIP user agent client looks like and how Conformiq Designer generates tests from the model. This here is a graphical part of our model, the UML state chart part of the model, created using Conformiq Modeler, which is the lightweight modeling tool that is part of the Conformiq tool bundle. And this is standard UML, so you have stage, you have transitions, and then you have the action language Java, which on the transition defines what happens when you go from one state to another. So let's have a look at an example of a transition and the associated transition string here. Initially, our user agent client is in a state called init, and then in order to get from this init state to calling state, the user needs to invoke or send a call command to the user agent client, and when that happens, the action on the second line of this transition string here is executed, and this action is a function call to a function called sendInvite, which is then implemented in another part of the model, a textual Java file. And this sendInvite then looks like this. We have a file called user agent client, which is another input file to Conformiq Designer, part of this model. And here we have a regular Java function or a method which first constructs a invite request and then sends this invite requests to the network. So it does the same thing that the real implementation would do, but it does it at the level of abstraction that we are using in the model. In addition to defining the functionality as defined by the specification in the state chart and in the Java files, a highly important feature of Conformiq Designer is that the requirements of for the original system that we are testing can be linked to the models that you create. Let's have a look at an example here. And this transition that takes us from the ringing state to the ready state. This is the transition that establishes a call by the caller sending an acknowledgement here by making a call to this sendAck function to the callee. In addition to implementing this thing in the model, we have annotated the fact that we are doing it here by adding a requirement statement into the model. And this requirement statement first defines, now it has a reference to the part of the specification that defines this behavior, and then an English description of what happens here. And when we embed these requirements into the model and then load the model, maybe we close this so that we have more space for interesting things at this point. When we load the model by clicking on this button here, the requirements end up as testing goals into the coverage editor of Conformiq Designer. This coverage editor is an important component of Conformiq Designer because it's basically the tool that you as a user use to tell Conformiq Designer which testing heuristics or testing goals Conformiq Designer is to use when it generates the test cases out of the model. Requirements are one category of these testing goals. In addition to requirements, the user-defined requirements, you could also use states or transitions or two transitions, or for models which have lots of boundary value analysis, you could choose to use the boundary value analysis as a testing heuristic. And essentially by choosing these, you define a level of detail that the test suite that you generate out of the model will have. In this example, we are only interested in the requirements of the model, and we are therefore only using these requirements here as the targets for our test generation. When we then start generating the test, what we will see is that these red zeros here, they start increasing, and eventually at the end of the test generation, they will all have a green 100 as their value, indicating that this test suite that we have generated covers all of the functionalities, all of the requirements that we have in the model 100%. So essentially Conformiq Designer tells us that these 9 test cases with 108 external test steps will guarantee sort of complete testing of the system under test with respect to these requirements. Then after test generation, you have these different views here in the user interface for you to work with. Model browser is a nice view because it basically allows you to analyze the different test cases at the level of the original model. So it gives you a read-only view of the model, showing that, for example, this test case number 1 would go through this path through the model. Then if you go click on these different parts of the MSC view here, for example, you will see how the different parts of this model browser are highlighted then accordingly. Then a typical thing in the usage of Conformiq Designer is that when you then execute these test cases, what you want to understand is how certain parts of the model of the system under tests are exercised by these different generated test cases. And in helping to help you analyze this, you then have this traceability matrix, which is then a mapping between the generated test cases here from 1 to 9 to all the different testing goals that you're using as targets for your test generation. If we, for example, want to analyze a test case that exercises the system for this requirement that we reviewed in the model, which was this one here, we look at the corresponding line in the traceability matrix, we look for an X here in the matrix, and then we see that it's this test case number 5 that would exercise the system for this. We click on this. All the other views here are then updated accordingly. So the test case view here, showing the names of the generated test cases as well as the generation date and time. Let's increase this so that we see everything here. So here's the date, here is the time. It's updated accordingly, highlighting the corresponding test case. Then we have the MSC view here, which shows the flow of this test case. Now it shows the whole test case. And the way you read this is that it tells us that the first test step in this test case would be sending a user input to the system under test with the data that we can see here in the test step view. Let's expand this so that we see all the different data items that are automatically generated by Conformiq Designer into the fields of user inputs and SIP requests and SIP responses as a part of the test generation process. So the first thing in the test case would be sending user input to the system under test, and then after that, what the test case or the test, what would be done at a test execution is that the test executor would expect a SIP request from the system under test, from the net out port of the system under test, with these different pieces of data in the different fields of the SIP request, and would validate that the request that we receive from the system under test matches the data that Conformiq Designer has automatically generated. So to wrap all this up, when you use Conformiq Designer, you first create the model. In this case, we have a model consisting of 4 different files, 1 graphical and then these 3 textual files. Having created the model, you then decide that, okay, these are the testing heuristics that I want to use when generating the tests. Requirements, states, transitions, boundary value analysis, whatever you need for your testing purposes and whatever makes sense for the model that you have created. And then you generate the tests. You click on the button here, and as a result of that, you will get a traceability matrix having a consistent mapping between the generated test cases and your requirements and other testing goals. Complete set of test cases here with test case names, test case creation date and time, complete flow of the test cases with all the data generated, and for timed test cases such as this one here, you will also have timings here indicating how the flow of the test case is supposed to go time-wise. And all this you get automatically with a click of a button here in the Conformiq Designer user interface. And that's what Conformiq Designer is all about.